All right, in this problem, we're given the densities of three gases, A, B, and C. These are all at STP, standard temperature and pressure. So we know that this conversion factor is valid. 1 mole of any gas at STP is going to take up 22.4 liters of volume. So let's just put that in a box. Probably end up using that. All right, and we're given these densities. Density is mass over volume, if you recall. So that's A. There's the density of gas B, and there's the density of gas C. And it wants us to calculate the molar mass and use that to identify which of these substances it is. Okay, so we got, let's just take this one step at a time. Let's do the first one. Right, so gas A has a density of 1.25 grams per liter. And so we need to get that to molar mass. So we want to keep molar mass is measured in, has units of moles, I'm sorry, grams per mole. So we want to keep the grams, but we don't want to, we want to get rid of the liters and end up with moles. Okay, so we're going to use this molar volume conversion factor that we had up there. All right, so we need to put liters on the top and moles on the bottom. All right, to get rid of liters. So the conversion factor is 22.4 liters is equal to 1 mole. Okay, so that's gonna give us 1.25 times 22.4. It's going to be 28. Let's get 3 sig figs in here. 28.0 grams. All right. So let's do this right now so we can get the matching out of the way. All right. We don't. These are all three of these are very different substances. So wait a minute. Ammonia, sulfur. Oh wow. All right. Sulfur. Okay, I'll list them over here off to the side. All right, we'll see if they get close in molar mass. We'll use more precision, but we probably don't need to do that. All right, so the molar mass for ammonia is going to be 14. That's nitrogen, and then 3. Those are your 3 hydrogens. So we have 17 grams per mole. All right, so there's your nitrogen. I'm sorry, ammonia, and I'll just keep all this in orange. All right, sulfur dioxide. That's SO2. All right, sulfur has a mass of 32. Oxygen has a mass of 16. There's 2 of them, so that's 32 plus 32 is 64 grams per mole. All right, what else we got? Chlorine. Chlorine is a diatomic element, so that's Cl2. So chlorine has a mass of 35.5. 35.5 times 2, it's going to be 71, I think. Right? Okay, grams per mole. All right, what else we got? Nitrogen is also a diatomic element, so that's 14 times 2. It'll be 28. Okay, so far so good. None of these molar masses are identical. So our last one is methane, CH4. Carbon has a mass of 12, and we're going to add 4 hydrogens, and that's going to give us 16. I was kind of close to the 17, but different enough. All right, so I'll put this in another box. We'll use that as a reference. All right, so back to our gas A has a molar mass of 28. Do we see that somewhere? Yep. So gas A is nitrogen. Okay, gas A. I'm gonna get rid of some of this. marker. All right, gas A is nitrogen. All right, let's go to gas B. Better pick a different color. All right, gas B has a density of 2.86. All right, 2.86 grams per liter. All right, we're gonna same setup, 22.4 liters, 1 mole, and that way we're left with grams per mole, which is molar mass. All right, so 2.86 divide, 2.86 times 22.4. All right, so I get a 64. Oh, wait a minute. Oh, we do have a 64. All right, so 64 grams per mole. All right, and so that is going to be sulfur dioxide. All right, so gas B is SO2, sulfur dioxide. All right, we have one more to go. Let's go check that out. Haven't used green. All right, well, that's pretty light, isn't it? So you can kind of maybe take a guess. All right, a light 714, 0.714. Gas C, 0.714 grams per liter. That's the volume. That's the density given, and we're going to use the molar volume to convert that to molar mass. All right, liters cancel out. We're left with grams on the top, moles on the bottom. All right, 0.714 times 22.4, 16. All right, so do we have a, it's right there, methane. Okay, so gas C is methane. Oops. CH4. Is that it?